There's a little jar of rooting powder at the garden center that costs about $12. And here's the thing nobody tells you, most of what's inside it, or something that does the same job, is already sitting in your kitchen right now, in a honey jar, in a coconut, in a bag of lentils you forgot about. Scientists have actually tested these. Some work shockingly well. One of them is a total myth. Let's get into it. 30 seconds of science. So the rest of this makes sense. Before we start raiding the pantry, you need to understand one word: auxin. Auxin is the plant hormone that tells cells at a wound site to stop being stem cells and start being root cells. The natural version plants make themselves is called indole 3-acetic acid, or IAA. It's produced up in the growing tips and young leaves, and it travels downward through the stem. That's why, when you snip a cutting and stick it in a jar, roots form at the bottom and not the top. The auxin pools at the cut end and starts flipping switches. Commercial rooting powders don't use IAA. They use a lab-made cousin called indole 3-butyric acid, IBA, because it's more stable and the plant converts it into usable auxin. That's it. That's the whole magic trick in the $12 jar. Usually somewhere between 0.1% and 0.8% IBA, and the rest is talc. Now here's the part that changes how you'll think about this entire video. Getting a cutting to root is actually two separate jobs. Job one is triggering roots. That takes auxin, either the plant's own or some you add. Job two is keeping the cutting alive long enough for job one to finish. Because a fresh cut is an open wound in a warm, wet, humid environment. That is a 5-star resort for fungus and bacteria. Plenty of cuttings never fail because they lacked hormones. They fail because they rotted first. So, on this list, some items are genuine hormone sources. Others are bodyguards that keep your cutting alive while it makes its own hormones. Both get you the same result, a new plant for free, and I'm going to tell you straight up which is which, because half the gardening internet blurs that line. Let's start with the spice rack. Number 1, cinnamon. This is the most famous one, and I'm going to start by taking away your favorite fact about it. Cinnamon is not a rooting hormone. It contains 0 auxin, not a trace. If you've been told it stimulates root growth, that's a game of telephone that's been running for about 20 years online. What cinnamon actually is a legitimate antifungal. The active compound is cinnamaldehyde, the thing that makes cinnamon smell like cinnamon, and in lab testing, it has real, measurable activity against the exact fungi that murder cuttings and seedlings: Fusarium, Pythium, Rhizoctonia, Botrytis. Those are the organisms behind damping off, that heartbreaking thing where a perfectly healthy seedling just folds over at the soil line overnight. So cinnamon isn't doing job 1, it's doing job 2. It's the bouncer at the door, while the cutting handles the hormones itself. Here's how to use it. Take your cutting, dampen the bottom inch, and roll it in ground cinnamon so it picks up a light coating. Not a crust, a dusting. Then stick it in your medium. You can also sprinkle it across the surface of a tray of seed starting mix as a preventative. And a word on realistic expectations, because I promised you facts. Most of the impressive cinnamon research was done in petri dishes, with pure fungal cultures on agar hit with concentrated extracts or essential oils. Your soil is a wildly more complicated place, and grocery store powder delivers only trace amounts of the active oil. It's a helpful layer of protection, not a force field. Use it on plants that root easily anyway: pothos, mint, coleus, succulents, and it will quietly improve your odds. Just don't cake it on. More is not better here. Number 2, raw honey. Honey is cinnamon's partner, and it's the one with the actual university study behind it. Researchers connected to the University of Hawaii ran a series of experiments comparing diluted honey against commercial IBA products across several plant species, including hibiscus and plumbago. The finding, in plain English, honey demonstrated a real ability to root cuttings. It generally didn't beat the synthetic hormone, but against doing nothing at all, it earned its place. Other trials have echoed that pattern. More roots, longer roots, fewer dead cuttings compared to untreated controls. Why does it work? Same reason as cinnamon mostly. Honey is famously antibacterial and antifungal. It is why an unopened jar can sit in a pantry for years without spoiling. It's also hygroscopic, meaning it pulls in and holds moisture, so it keeps the cut surface from drying out while it's sealing it off. Some researchers suspect honey's enzymes and sugars contribute something extra to cell activity. But honestly, that part isn't nailed down yet. The protection is the proven part. Use raw honey if you can. The antimicrobial compounds in honey are heat-sensitive, and standard supermarket honey has been pasteurized, which, by the way, is the flaw in the recipe you've seen 1,000 times, the one that says, stir a tablespoon of honey into 2 cups of boiling water. You just cook the good part. If you want a dip, use warm water, not boiling. Better yet, skip the water. Dip the cut end straight into the jar, give it a twist so it's coated in a thin film, and plant it. And now the combo move: dampen the cutting, roll it in cinnamon, then dip it in honey. The honey seals the cinnamon in place instead of letting it wash off with the first watering. It's 2 different antimicrobials working the same wound. For softwood cuttings and houseplants, that's about as good as free gets. Number 3, aloe vera gel. Okay, now we're getting into things that actually contain hormones. That aloe plant on your windowsill, the one you only remember when somebody burns their hand on a skillet, is a small chemistry set. Analysis of aloe gel has turned up salicylic acid, gibberellins, amino acids, enzymes, plant sterols, sugars, and small amounts of indole 3-acetic acid. That's real auxin, actual auxin. Now calm down slightly. The hormone content in aloe is low, and it varies a lot depending on the plant, its age, and how you handle the leaf. This isn't a concentrated dose, but there's published work behind it. A 2017 study by El Sharif found aloe gel application increased root weight in cuttings, and later trials on olive cuttings put aloe gel at the top of the natural treatments for root weight, ahead of both plain salicylic acid and untreated controls. Aloe is also doing job 2 at the same time. Its saponins are mildly antimicrobial, and the polysaccharide gel, isomanin, physically holds moisture at the cut surface, so you get a hormone nudge and a protective coating out of one leaf. Here's the method. Cut a mature outer leaf close to the base. Stand it upright in a cup for 10 or 15 minutes and let the yellow latex drain out. That bitter stuff is aloin and you don't want it. Then split the leaf and scrape out the clear inner gel. You can dip the cutting directly into that gel or blend a couple of tablespoons with a cup of water and soak the cutting for 5 to 10 minutes. Use it fresh. Blended aloe gel starts fermenting fast at room temperature, and there's nothing hormonal about a jar of funk. Make it the same day. This one is genuinely excellent for softwood cuttings and houseplants: pothos, philodendron, monstera, rosemary, salvias. Number 4, coconut water. If there's a heavyweight champion on this list, it's this one. And it's not a garden blog thing, it's a laboratory thing. Coconut water has been used in plant tissue culture since the 1940s. When researchers were first trying to grow plant embryos in glass dishes and couldn't figure out why nothing would divide, coconut milk was the mystery ingredient that made it work. Decades later, they figured out why. It's loaded with plant growth regulators. Chemical analysis has identified cytokinins, including zeatin and transzetin riboside, plus auxins, including IAA, gibberellins like GA1 and GA3, abscisic acid, amino acids, and a pile of potassium and trace minerals. That's not a folk remedy. That's a hormone cocktail you can drink through a straw. And it's been tested on cuttings specifically. Work on Dracaena found coconut water extracts improved adventitious root development. A study on Ixora concluded coconut water improved cutting establishment and called it the cheapest, most accessible option available. Black pepper cuttings soaked in a 25% coconut water solution showed increased shoot length. Studies on juniper cuttings found coconut treatment improved rooting compared to untreated material across growing seasons. In one tissue culture trial, a 20% coconut water solution was the single most effective organic additive tested for promoting both shoot and root formation. Now the fine print, and this matters. Fresh young coconut water only, not the shelf-stable stuff in the sports drink aisle that's been pasteurized, sometimes concentrated and reconstituted, often sweetened, and the delicate hormones you're after do not survive that intact. Buy a young green coconut, crack it, use the water within a day or two. Trials generally point to young nuts, harvested around 7 to 8 months, as the richest source. Method: dilute it roughly 1 part coconut water to 3 or 4 parts water and soak your cuttings for a few hours. Some protocols go up to 12. Then plant. Longer soaks correlated with better root development in at least one study, so if you're impatient, that's the one thing you shouldn't be impatient about. Number 5. Sprouted lentil water. This is the one almost nobody knows about, and it's the most scientifically elegant hack on the entire list. Here's the logic. A dry lentil is a dormant seed. Nothing's happening. But the second you soak it and it starts to germinate, that seed fires up its entire hormone factory because it has to build a root and a shoot from scratch, and it has about 72 hours to do it. During germination, auxin production spikes. So sprout the seeds, then steal the hormones. And this isn't fringe. Mung bean cuttings are the classic laboratory test system for studying adventitious rooting. There is decades of published research using mung bean hypocotyls precisely because they're such a clean, reliable model for how auxin drives root formation. The plant physiology world has been leaning on sprouting legumes to study rooting for a very long time. Growers just worked it backwards. The method, and it's basically making lunch. Take a cup of dry lentils, green or brown, cheapest bag at the store. Soak them in water for 8 to 12 hours. Drain them completely, put them in a jar, and let them sit somewhere warm for 2 to 3 days, rinsing once or twice a day. You want short little tails, 1/4 inch or less. Once those sprouts get long, the peak is behind you. Then blend the sprouts with about a cup of water into a slurry. Strain it through a cloth or a fine sieve. What you've got is concentrated, so dilute it heavily, roughly 1 part sprout liquid to 10 parts water. Soak your cuttings in that for a few hours, or use it to water freshly planted ones. 2 things worth knowing. First, this stuff is alive and full of sugars and proteins, so it spoils fast. Make it, use it same day, and don't store a batch in the fridge hoping it's still good next week. Second, the type of seed matters less than you'd think. Barley, peas, chickpeas, pinto beans all work on the same principle. Corn is the interesting outlier. Sprouting corn is known for producing a strong cytokinin profile rather than auxin. And go easy with alfalfa. Sprouting alfalfa hits a hard peak of a growth compound called triacontanol, and overdoing it can work against you. Half strength. Number 6. Baker's yeast. This one sounds like a joke. It has a peer-reviewed paper. Researchers at the University of Sulaimani tested baker's yeast on hardwood olive cuttings, and olive hardwood is notoriously stubborn to root, which is exactly why it is a good test. They soaked cuttings in yeast solutions at several concentrations for 1 or 2 hours. The winner was 2 grams of yeast per liter of water, which produced the highest rooting percentage in the trial at about 43%, along with the highest root number and root length. 43% might not sound like a party until you remember these are hardwood olive cuttings, which routinely refuse to do anything at all. Why would yeast do that? Not hormones. Yeast is a nutrient bomb. B vitamins, amino acids, enzymes, proteins. And there is an established principle in horticulture that mineral nutrients and vitamins improve rooting in cuttings. Yeast extract is used in laboratory tissue culture media for exactly this reason, as a source of vitamins and amino acids, and as an elicitor that provokes a growth response. It is feeding the process rather than triggering it. Method: 2 grams of active dry yeast, that's a little under a teaspoon, dissolved in 1 liter of lukewarm water. Let it sit 10 minutes so it wakes up. Soak your cuttings for 1 to 2 hours, then plant. Do not add sugar. Sugar is for making bread rise, and here it will just invite mold to the wound you are trying to protect. And do not leave cuttings soaking in it overnight. A couple of hours is what the study used. And yeast in a warm jar goes from helpful to swamp remarkably fast. Best use case: woody, difficult cuttings, olive, fig, rosemary, pomegranate, hydrangea, the stuff that laughs at honey. Number 7, aspirin. Now we're in the messy part of the list, and I want to be careful here because this is where a lot of gardening content gets confidently wrong. Aspirin is acetyl salicylic acid. In water, it converts to salicylic acid, which is genuinely a plant hormone. Willows are packed with it. That's where aspirin came from in the first place. But salicylic acid is not an auxin, and it does not do the root-triggering job. Its actual role in plants is defense signaling, and it is the alarm system that tells a plant to raise its immune response when something attacks. So the popular claim that aspirin makes roots grow is, at best, half a sentence. Now here's where it gets genuinely interesting. Some research suggests salicylic acid can help, but indirectly. In a 2020 cucumber study, exogenous salicylic acid at 50 and 100 micromolar promoted adventitious root formation, and the mechanism was clever. Salicylic acid competitively blocked an enzyme that normally deactivates the plant's own auxin by tying it up. Block the deactivator, and free auxin levels rise locally. More auxin at the wound, more roots. Rio found back in 1989 that salicylic acid could stimulate rooting in mung bean cuttings too. But, and it's a big but, the literature is genuinely contradictory. Other researchers found salicylic acid inhibited adventitious root formation in mung bean hypocotyls. De Klerk found salicylic acid suppressed auxin-induced rooting in apple microcuttings in the early days after treatment. And a 2023 paper in PLOS Genetics showed that a plant's own naturally accumulated salicylic acid at a wound site actually blocks root regeneration by interfering with auxin transport to the site. The theme across all of it: low concentrations can help, high concentrations shut everything down, and which is which depends on the species. Which brings me to the recipe everyone repeats: 1 325 milligram aspirin in a gallon of water. Do the math on that and it lands around 475 micromolar. That's roughly 5 times higher than the concentrations that help those cucumbers. If you're going to try aspirin, go far more dilute than the internet tells you. A quarter tablet in a gallon is closer to the range that has evidence behind it. Honest verdict: aspirin is a supporting actor. It's most defensible as a companion to something that actually supplies auxin. One study on chrysanthemums found IBA plus a small amount of aspirin outperformed IBA alone. On its own, don't expect miracles. Number 8. Apple cider vinegar. Last one, and I'm putting it last on purpose because it's the weakest, and I'd rather tell you that than sell it to you. You will see it claimed that apple cider vinegar contains naphthalene, acetic acid. It does not. NAA is a synthetic auxin made in a lab. It is not in apples. It is not in vinegar. It has never been in vinegar. That claim has been copy-pasted across the internet for years, and it's simply false. What apple cider vinegar actually contains is acetic acid, trace minerals, and a mild antimicrobial punch. Gardening, Know-how: put it about as straight as anyone. Apple cider vinegar for rooting works according to plenty of gardeners, but there's very little horticultural research supporting it. So why is it on the list at all? Two honest reasons. First, the antimicrobial angle. A very dilute acidic dip discourages bacteria at the cut surface. That's job two again. Second, and this one is well established, acid soaks are a legitimate technique for scarification. If you are germinating seeds with a tough coat, a vinegar soak helps thin that coat and speeds up germination. That's real, and commercial growers use acid soaking for exactly this. If you want to try it on cuttings, the dose is the whole story. About 3 teaspoons of apple cider vinegar in a full gallon of water. Dip the cutting for a few seconds, not minutes, and plant it immediately. Vinegar, at anything approaching full strength, is a contact herbicide. It will burn the tissue you're trying to root. Go too strong here, and you don't get a plant, you get a stick. The ones that don't work, save yourself the trouble. Quick myth cleanup, because these two are everywhere. The potato trick. You've seen the video. Jam a rose cutting into a potato, bury it, wait for magic. There's no hormone story here at all. A potato is starch and water. What it mostly provides is a moist pocket and a big pile of sugar sitting against an open wound in warm soil, which is an invitation for rot, not roots. Nobody has produced a controlled trial showing it beats just sticking the cutting in soil. Banana peels. Bananas are rich in potassium. Potassium is a nutrient, not a hormone. A rootless cutting has no way to take up much of anything from the soil yet, so you're mostly composting near a stick. Save the peel for established plants. And one honorable mention that isn't in your kitchen, but deserves a nod: willow water. Willow bark and young willow shoots contain both salicylic acid and indole 3-butyric acid, the actual IBA in commercial rooting powder. If there's a willow anywhere near you, crush a handful of young green twigs, steep them in water for a day or two, and you've made the closest free equivalent to the store-bought stuff that exists. The part that matters more than any of this, real talk for a second. No dip on this list will save bad technique. So use clean, sharp scissors. Cut just below a node. That's where the root cells wake up. Cut at an angle to expose more surface. Strip the lower leaves so they're not underwater rotting, but leave the upper leaves on, because that's the factory producing the auxin that has to travel down to the cut. Keep humidity high with a bag or a dome. Bright, indirect light, never direct sun on a rootless cutting. And use a light, airy medium like perlite or coco coir, not dense soil that suffocates a new root. Do those things and half your cuttings will root with nothing but tap water. Do those things and dip in honey and cinnamon or soak in coconut water, and you'll start wondering why you ever paid $12 for talcum powder. So there it is. Some of these are real hormones, some are bodyguards, and one is mostly vibes. Now you know which is which. Pick one, grab a cutting off a plant you already own, and turn one plant into 2 for free this weekend. Thanks for watching. If this video taught you something useful, hit that like button and share it with a friend who's about to buy rooting powder, and subscribe with notifications on so you never miss a video.